Question 2. On paper 2, the circle has a centre of 7 minus 8 and passes through the point 2 minus 2. I definitely have to give myself a sketch of that. So I'm actually just going down to the bottom here. Centre 7 minus 8 and passes through the point 2 minus 2. Maybe somewhere around there. Haven't a clue, but I'm just trying to give myself some sort of an idea. Find the equation of the circle. Well, go to your log tables, and there's 2 formulas for the equation of a circle. Use whichever one you want, whichever one is probably easiest or fastest for you. I'm going to use this one, x minus h to be squared plus y minus k to be squared is equal to r squared, which means I need hk. If I look at my log tables, that just indicates the centre point. Have it. There's h, there's k. And then I also need the radius. Sure, I'll just use my junior cert distance formula. Again, what a ridiculously nice question to start off with. So I call it, well, I'm going to just fill this in and make sure I have my attempt marks first. So x minus h to be squared plus y minus k to be squared is equal to r squared. I need to get my radius now, so that's x1, y1, x2, y2, and we get the square root of x2, 7, minus x1, which is a 2 to be squared, plus y2, which is minus 8, minus, and then y1, which is a minus 2 to be squared. So we end up with square root of, can you just throw that into the calculator, 5 squared plus minus 6 squared. And that gives me the square root of 61. No need to multiply this out, but I am going to clean it up as much as possible. So the radius is the square, so that's my radius. And so my radius squared is going to be 61. If you did it the other way, that's fine as well. It would be the exact same answer as this is multiplied out. So same. Q is a point on the circle. So this is P. This is point P. That's my center point. All right, so now Q is the point on the circle S. So here's my circle that is closest to the x-axis. In surge form, find the coordinates of Q. So probably just going to give myself a little bit more information. What is the square root of 61? Because that's the length of my radius. I'd like to know that. Square root. So now I'm going into a bit more detail because I'm not 100% sure what to do here. So that is about 7.8 units long. So if we are here, okay, so it's not 8 units long, so it's definitely, yeah, so it's not touching the x-axis, but it's not that far away either. And it is going through the y-axis. Just about. Now I'm getting all that information from looking at where this point is and the length of my radius. Okay. So there's this point here is the closest to my x-axis. And isn't that what they are asking? Yes, it is. So what do I know about this point? Well, if it's directly above this, so its first coordinate is 7. And what else do I know? That's root 61 or 7.8 now, dot, 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 dot. So that's root 61, which means that if we go back up, so that full line is -8, and we want to go down just a little bit. So -8. And then plus the root 61 would bring me up to as far as there. So 7. And then -8 plus root 61. I hope that makes sense there, because I'm literally just getting all of that from a diagram. I haven't really done any, like I haven't used anything from my log tables. I've just gotten every bit of that from a diagram. Okay, and then the next bit, the point or is also on the circle. Okay, so I might go back to my diagram there, but maybe I don't need to. Let's just see, because they've given it to me here in I suppose better detail than what I had drawn. So we now know that, well, if we know our C center point, we also know that point there. I have the equation of my circle, so I could potentially find those 2 points there if I need to. Anyway, so the point R is also on the circle. Okay, so we've 2 options for R. The length of the chord PR is 10 units. So that's 10 units there. It shows 2 possible decisions, or find the possible equations of PR. Okay, so definitely a problem solving question. My method for a problem solving question is I go to the log tables and I start disposing of ones that I think shouldn't be of any help. So, should the slope help me here? I don't think so. Like, I have this point here and I have the radius. They are all 3 going to be the same. And they're root 61, just in case. I'm just trying to fill in my diagram as much as possible just to see, will slope help me? I don't think so. Okay. Will the length of a line help me? Potentially. Okay, I'm going to put that one maybe as a question mark here. The only reason I'm going to do that is because maybe I know the length of that is 10. I'm still not really too sure about using that, so I'm going to move on swiftly. Midpoint. No, can't see how I use midpoint. Equation of a line. Yeah, well, I need to use that straight away anyway, so I might as well write that down. Y minus y1 is equal to m bracket x minus x1. Area of a triangle. No, I'm going to say no. And a point dividing a line segment in a given ratio. No, can't see how to use that. Perpendicular distance formula. To be honest, I'm always going to seriously consider that. So I rarely discard of this one straight away. So so far I have two question marks. I have my length one from junior cert. And then here I have perpendicular distance. Why do I have perpendicular distance? Well, I guess I know the perpendicular distance from that point to that line. You know, I know the perpendicular distance. Maybe. Anyway, it's a maybe. It's always a maybe for me because it's so common. Tan of the angle. No, I don't see any angles. Equation of a circle. I've already done that in the first part. So I know the equation of the circle. That's not going to help. Equation of a circle. Same. Okay. Now, I'm still not convinced as to what method to use. So I'm going to keep going down through my list. So I can't remember if I've gone through this with you. I think I have. But 1, I check what's in the log tables. 2, I look at my junior cert rules, etc. that aren't in the log tables. 3, I really, I might just use that perpendicular distance formula. It's the most common. And 4, if I'm really, really stuck and I haven't a clue what to do, I also need to consider Pythagoras' theorem. They're my go-to 4. And if I really think about those and try my best to fill some or a good few of those in, I should be getting at least a 10 marks, or otherwise it's the most horrendous coordinate geometry question that I've probably come across. So I've done 1, I've checked the log tables, and I've used the equation of a line. I'll have a go fill that in a minute. And other ones that I'm still considering, but just because they mentioned the length of the line P to R, I'm considering those too. Okay. Junior cert stuff. Find out where it cuts the x-axis. I did that in part 1. Maybe that's a benefit. And it doesn't cut the x-axis. It just got me another point on the circle. Find out where it cuts the y-axis. Maybe. I'm not going to do it yet. It's just still a maybe for me. What else can I do? Point of intersection. No. If I have parallel lines, I don't see parallel lines. Do I have perpendicular lines? I don't see perpendicular lines. Okay. I kind of feel like I've gone through the most of these. Number 3 here, I'm moving on to lean towards. Okay, I haven't become definitive about anything yet, so that's kind of highlighting towards me. Pythagoras' theorem. Can use Pythagoras' theorem if I have a right-angled triangle. Well, maybe. Just get the right pen. The fact that when I was looking at the perpendicular distance formula, I'm after creating a right-angled triangle there. Now, that just brings to mind a rule about a radius will bisect a chord. So the fact that this here is a chord, then, wow, that's... I mean, if I'm using Pythagoras' theorem, that's trigonometry. If I'm using the rule that this is 5 here, and this is 5, that comes from my geometry where the radius of a circle bisects a chord, and I'm in a coordinate geometry question. So that's an awful lot of different parts or different areas of maths that I'm using to try and figure out this question. Okay. Why would that be of benefit to me? Well, I also know this. I know this is root 61. So it allows me to find this. Not sure it's going to help, but might as well have a go. So that's the square root of 61 to be squared is equal to 5 squared plus x squared. Right. So that's 61 is equal to 25 plus x squared. That gives me 36. I subtract there, is equal to x squared. So x is 6. So that bit of a line there is 6. Okay, now that's different. That leans me towards the perpendicular distance formula. So if I have the perpendicular distance from this point, which I know, to this line is 6. All right, so that's all good. And now look at the amount of problem solving I had to do there. I had to check my log tables. I wasn't sure. Always keep the perpendicular distance formula in mind. I went through my junior cert rules. Nothing there seemed to help. I went with the perpendicular distance formula, but I just need to keep it in mind all the time. Then I tried Pythagoras' theorem. Yes, I used that. Then that led me to like part of geometry to do with a circle, and the radius will bisect the chord. So then I could fill out Pythagoras' theorem, find the length of that being 6. And then that led me to the perpendicular distance formula. Oh my God, like that's tricky problem solving question. Very, very. To be honest, from the start here, if I, maybe you wouldn't have gotten all the way to this point, but what you should have done is gotten your 4 marks from the start and gone, y minus y1, because we know p, and it's 2 minus 2. So y minus y1 is equal to m bracket x minus x1. So you definitely should have gotten your attempt marks there. We were missing the slope. And here I'm on my 4 out of 10, or I think this question is actually worth 15. So maybe 4 or 5 out of 15 to start off with, just by doing this part here. To get the rest of the way was not straightforward. So I am now going, right, the perpendicular distance from C is 7 minus 8. So the perpendicular distance from C to the line, and I don't have the full line, I have y, it's plus 2, equals mx minus 2m. The perpendicular distance from the point C, I've lost, C was 7 minus 8, to that line is 6, and I got that using Pythagoras' theorem. Okay, go to your log tables, get your perpendicular distance formula. And that is equal to 6 in this situation. Now, if you look at your log tables, you can only use the perpendicular distance formula if your equation is in this form. So if everything is to the left and it's equal to 0, mine is not at the minute. So that's a minus mx plus y plus 2 plus 2m equals 0. Now it's in the right format. A is the coefficient of the x times x1, which is 7. B is the coefficient of the y, which is a 1, times minus 8. And C is whatever is left. That's a 2 plus 2m. All over the square root of a squared plus b squared. And that's equal to 6. That gives me the absolute value of minus 7m minus 8 plus 2 plus 2m all over the square root of m squared plus 1 equals 6. And that gives me minus 5m minus 6 all over the square root of m squared plus 1 equals 6. I'm going to square both sides. To square the top, top by top, bottom by bottom, I end up with 25m squared minus 60m plus 36, I want to say. I'm going to double check that now in a second because I did that very fast in my head. And that's m squared plus 1 is equal to 36. Let me just make sure of that. So 25m squared plus 60m, sorry, plus 36 equals 0. Okay, keep going. I end up with 25m squared plus 60m plus 36 is equal to, so I'm going to multiply both sides by m squared plus 1, 36m squared plus 36. Bring it all to the left. I have, or bring it all to the right maybe. 11m squared minus 60m equals 0. Oh, look at that. It's actually so obvious. That's the slope of 0. Anyway, look, I'm gonna go down here. So that is 11 is in common, and m into m minus 60 is equal to 0. Let each factor equal to 0. M is 0, so one of the slopes is 0, which was actually obvious maybe from the question, and the other slope was 60. So I just go back to here. Doesn't matter if it's back here or to here, and I fill in my 60 and my 0, and that'll give me the two possible equations of PR. So I might just do it at the side here. When I do that, I end up with, oh, that's silly of me, sorry, don't take the 11 out in common. So m is 0 and 11m is 60, so m is 60 over 11. Sorry, I shouldn't have taken the 11 out in common. That was very, very bad basic maths. Okay, so I have my two slopes, and I'm just going to fill in. And when I fill in, I end up with, so y minus y1. So I'm just going to go y plus 2 is equal to m bracket x minus 2. So 0 bracket x minus 2. Here's option 1. Y equals minus 2. And that looks pretty good from the diagram. And then the other one is y plus 2 is equal to 60 over 11 x minus 2. So that's y plus 2 is equal to 60 over 11x minus 120 over 11 multiplied by 11. 11y plus 22 is equal to 60x minus 120, and that's 60x minus 11y. 60x minus 11y minus 142 equals 0. There's my second equation. So that one, look, that one there looks to be the equation of this line here, and that one here looks to be the equation of this one here. Very long problem solving question.